All right, good morning, guys. Here we go. Let's do a quick audio check. Give me a thumbs up if you can hear me. All right, cool. So I assume you can hear me. Let's make sure you can see me real quick. Jump in here with you guys. I'm eating a little snack due to my class running kind of close to this one, so bear with me. Question of the day: do you eat string cheese by pulling it, or do you eat the whole thing? That's a serious question. That's right, Caitlin. We love snacks. All right. So it looks like Christina says, I pull it with my teeth. That's disgusting. Abby, you have to pull it. Josiah said he's watching the stream but can't type. Tell Josiah to go on his mom's account. Kelsey says depends on how much I have. And then Abby says if you eat the whole thing, you're a psychopath. Her words, not mine. Okay, and then Elizabeth repeats what Abby says and says, pull it. If you eat the whole thing, you're a psychopath. It's real cute, ladies. So, questions on 6.1 homework. Questions on 6.1 homework. Okay, Elena says 3. Okay, so with 3 right here, Elena says 3 and 7. So with 3, typing in stuff that would making your XY table where your X values right here are going to matter, right? So if you type in a 0 there, obviously when X is 0, anything to the 0 power is 1, so that's 1/4 or 0.25. So 0 and 0.25 should be our, let me scoot up a little bit. 0.5 should be our, what we're dealing with there. If I say 1, 1/2 times 1/4 is 1/8. So that's like 0.125 is an eighth. So as you can see, it's going really close right here. So that's that. Then go the other way. -1 would be 2. No, excuse me. If it's -1, I forgot the 1/4. That would be 1/2. So -1 would be 1/2. Or around 1/2. negative 2 appears to be 1. Negative 4 appears to be 4. So it should be looking something like this right here. And again, just a sketch, not necessarily a perfect graph. And then from there, we just got to identify everything. The domain. Domain is negative infinity to infinity. Range would be from 0, not included, to infinity. Our intercept would be 0, 0.25. Our asymptote would be the x-axis, y equals 0. In behavior as f of x as x approaches infinity for 1/4 times 1/2 x. As it's approaching infinity, that is approaching 0. And as it approaches negative infinity, 1/4 times 1/2 squared, or x, sorry, not squared, that would be approaching infinity. Not sure what you needed there, Elena, but does that help for number 3? Okay, looking at number 7 then. So number 7, I told you on this one, I feel like I meant to use your calculator for these two. No, it's just the 1/3 times 2 raised to the x, but then the -1 pushes it to the right 1. -1 goes down 1. So it should be a graph that looks something I don't know where this, I assume should be looking something about like this. Of course, more smooth than what I just did, but you get it. Abby said for numbers, or Elena said for number 7, I was confused about the horizontal asymptote because it touches 1. So the horizontal asymptote would be y equals 1. The horizontal asymptote would be y equals 1. So it doesn't touch 1. It should just approach 1. It does touch it. So then it could be 2 here. Sorry, my calculator's dead. So here, yeah, I'm sorry. I'm talking about -1 here, but I'm just looking at the answer sheet to kind of look at it. So it may be 2. Let me look at the calculator real quick. My calculator's dead. I need to go to school and get my charger, but we can look on this right here. Y equals math 1 divided by 3. So I'm seeing that it is 1 based on this right here. it approaches -1, but it never touches it. Those are just the reason that these all say -1 is because it's just rounding it. The calculator can't handle that much. I need to go the other way. So all those are, so as you see here, Elena, it's approaching -1. It does not hit -1. Okay, no problem, guys. No problem. Cool. Any other questions on the homework? Yes, that's correct. It is y equals -1, Abby. Any other questions? If not, give me a thumbs up if you're ready to move to the notes. Okay. Yes. You did have to do the other information. Yes, correct. Yes, Lucy, you had to do all the other information on these as well. Abby, number 8, the horizontal asymptote would be 1. Okay, looks like everybody else is good. No clue who baked beans and toast is. Some idiot. All right, so moving right along. If we're all good, let's go to 6.2 notes. Okay. Baked beans and toast have been taken care of. Sorry about that. Is that Josiah saying, bro, you're really funny? I don't know if you're joking or what, Josiah. Is that you? Is Cypress Dublin 10712? Is that you, Josiah? He gone. He gone, London Grace. Okay, cool. You better start doing your work, Josiah. Quit playing around. Make sure you're in class. So my wife is telling me, not to be the bearer of bad news, but my wife is telling me that the governor just announced that we won't be returned to school. So don't mean to be the bearer of bad news. I'm sure you probably already had heard anyway. But anyway, we shall continue in this. Continue with our lesson. All right. So 6.2 notes, give me a thumbs up that you got 6.2 notes out and you're ready to go. Thumbs up that you got 6.2 notes out and you are ready to go. All right, so here we go. Jumping right into 6.2 notes, and 6.2 notes has to do, we're going to extend our knowledge a little bit on what we discussed in the last lesson, which was exponential growth and exponential decay. I'm sorry, Elena, get better internet. So, looking at exponential and exponential decay, we're going to now take this more to the real world, okay? So, and this is where, to me, the math can get a little bit interesting. So, I'm going to take $5,000. $5,000, and I'm going to put it into a savings account or a certificate of deposit, also known as a CD, or some kind of account in which the bank has. Okay, so I'm putting $5,000 into a bank account. Okay, and write this down as we kind of go into this. Okay. So putting $5,000 into a bank account, and they pay 4% interest, and what they would almost even call a 4% annual interest. Okay, so $5,000 into a bank account, 4% annual interest. Here's the question I want to know: how much money will be in the account? How much money will be in the account after 3 years? I actually think you're going to like these, Christina. I know you say they're trash right now, but I think you'll like these. Okay, so if you were just to ask me this question, all right, I would set up a basic table with a calculator, all right? So the year 0, okay, that's when I just put the money in, okay? Year 0, the amount I've put into the bank is $5,000, and that's the amount I have, year 0. All right. So from January, okay, from January, whatever this year was, okay. Actually, let's use this as more of a specific year. Let's say year 2020. All right. January of this year, I put $5,000 into an account. All right. That earns 4% annual interest. Now, year 20, and we can just say this is all January. January of year 2021, how much money do I now have? Well, with them paying 4% annual interest, 4% is the same thing as 0.04 as a decimal, moving it back twice. So I just need to, in order to figure out how much interest earned in that first year, interest earned in the first year, I will need to just multiply 5,000 times 0.4. Okay? When I do that, when I say 5,000 times 0.04, I get $200. So I earned $200 from January 1st to December 31st during year 2020. Okay? So then I start the new year with $5,200. Now, I've not invested any more money, but my money has now grown to $5,200. So then another year goes by, year 2022, but now I have $5,200 in the account. I have $5,200 in my account now because the last year's interest that I earned. So now I multiply this by 0.04. And I now have 208 is what I earned from that year in interest. 208. So 5,000 plus 200 is 5,200. 5,200 plus that 208 would be 5,408. And then the next year, which this year would be my last year, 3 years, because it said 3 years here, January of 2023, we simply multiply 5,408 times that annual interest rate of 4%. And I get 216.32. I then add that to the 5,408. And at the beginning of January, I would have $5,624.32. Now, that is the way interest works. Okay? So, just to recap. January of 2020, I put in $5,000. It pays 4% annual interest. I earned $200. So the next year I started with $5,200, and that got 4% interest. So then the following year I got $5,400, and then it calculated 4% interest based on that, which was $216, adding it to my total right there of $5,624.32. And what this is called, it's called compound interest. Okay? So compound interest. Just going to write a few notes about compound interest. So compound interest is when interest is paid monthly, or it could be paid once a year. When interest is paid monthly, the interest earned after the first month becomes part of the new principal. Principal is the amount from the beginning. The principal is how much money you have in there. Is part of the new principal for the second month. And so on. Interest earned on interest. Earned. That is your basic definition of compound interest. Interest earned on interest earned. That is compound interest. Okay. So when interest is paid monthly or yearly or quarterly, whenever it is, the interest earned after the first month becomes part of the new principal for the second month, and so on. Interest earned on interest earned. So you're making money off the interest that you've already earned. Now, interest can be compounded many different ways. Some banks compound it, and these are just kind of some examples here. Compound, and that's just when we say compound, what we're saying is each, like on this one right here, so you put $5,000 in January, the bank on December 31st, they do it once a year. They say this: we are going to compound it annually, meaning once a year we are going to pay you interest on what money is in your account. Okay, so annually is once a year, once per year. Semi-annually, and I think I'm spelling annually wrong, but don't hate, just appreciate. Semi-annually would be 2 times a year. Quarterly would be 4 times a year. And monthly would be 12 times. Now, someone type in the chat box, which one do you think is best for you and your money to grow? Which one is best? Banks that say we're going to compound it annually, 1 time a year. Banks that say we're going to compound it semi-annually. So we're going to pay you 4% semi-annually. So after 6 months, we'll pay your interest, and then after another 6 months, we'll pay you another interest. Quarterly 4 times, monthly 12 times. So Josiah says annually. Kelsey says monthly. Okay. Anybody else? Monthly. Yeah, okay, yeah. That makes sense because if you put $5,000 in there and then they give you interest after 1 month on that $5,000, then now it's like at $5,000 something else. But someone tell me the reality of this. As you get away from annually, what is probably going to go down? As you get further and further away, so if you're at annually, like this example was annual, okay? 4% annual interest. But as you go to semi-annual and quarterly and monthly, yeah, Maddie, your interest is going to decrease. What they're going to pay you. So you wouldn't find a bank that says we'll pay you 4% annual interest, and then they'll say, well, we'll pay you 4% monthly interest. There's no way. Okay, so that is this right here. Now, here's the cool thing about all this is that this table right here is just a very basic formula. Okay, so our compound interest formula. So we don't have to make a table every single time. We can just simply follow this formula right here. A, the amount, is equal to P, the principal, times 1 plus R, your rate, over the number of times it's compounded, raised to the NT power. So A is amount. P is your principal amount. R is your rate. N is your compounds. T is time in years. Let me get myself out of the way. Not like that. Like that. There we go. So compound interest formula is A equals P times the quantity of 1 plus R over N raised to the NT power. Okay, so here we go. Looking at number 1. So Castell invests $2,040 into a savings account with a fixed annual interest of, correct, Abby, both ends will be the same. Castell invests $2,040 in a savings account with a fixed annual interest rate of 9%, compounded 3 times per year. What will be the account balance, or what will the account balance be after 9 years? First step I always want to see you do is always write the formula. A equals P, our principal, times the quantity of 1 plus R over N raised to the NT power. Okay, and then guys, I feel like this lesson is a little bit more in your coming of knowledge than it is your ability to do a specific skill, because basically we're just typing it typing in the formula, and the thing is just knowing the formula. So her amount after 9 years will be equal to her principal, 2,040, times 1 plus. Now the rate is always as a decimal. Okay, rate right here, this R is always as a decimal. So 9% as a decimal would be 0.09 over how many times it's compounded. It's compounded 3 times a year, so that would be 3. And then raised to the number of compounds, which is 3, times the time and the number of years, which would be 9. Again, principal amount, she invested $2,040. She then put, then we just say 1 plus the rate, 0.09 divided by the number of compounds, raised to the compounds times the time. Give me a thumbs up if you have your calculator home with you, or you have some kind of calculator on you. Won't be able to necessarily do this on the iPhone calculator, but if you have a calculator, give me a thumbs up. All right, Maddie has hers, Kelsey. Good, Abby. Okay, Elizabeth, good. So somebody calculate this. I'm going to show you once on the I have this calculator on my phone. We can use this just for a second. So second quit. So if I do 2040 times 1 plus alpha fraction 0.09 divided by 3, and all of that is to the 3 times 9, or 27 power. We enter, and I just want you to round to the nearest hundredth, guys, since we're dealing with money. So that amount would be 4531.43. Okay? And that is that, guys. Okay? Look at number 2. Stefan invests $5,809 into a retirement account with a fixed annual interest rate of 4% compounded 12 times per year. What will the account balance be after 18 years? So always write your formula. A equals P times the quantity of 1 plus R over N raised to the NT power. Do whatever you can to memorize this formula. I always kind of remember like R, R, with the specifying the N. R, 1 plus R, okay? So then we just type in our values. So our principal amount is 5,809 times 1 plus my rate is 4%. So that's 0.04 over the number of compounds, which is 12, times the number of compounds, which would be 12 here, times 18 years. Someone type that in, and someone type that into your calculator. And type the answer into your chat box once you get it. Maddie, you make the fraction on the TI-84 by hitting alpha y equals, and then enter, and then that'll raise up your fraction. Alpha y equals. Somebody have the answer? Thought you all said you had calculators. Yes, very good, Kelsey. That's right. $11,919.92. Very good, Kelsey. Good, Maddie. All right. Let's jump down here. Number 3. Sarah Wong invests $1,781 in a savings account with a fixed annual interest rate of 9% compounded 2 times per year. Okay. What will the account balance be after 7 years? All right. So A equals P times the quantity of 1 plus R. There we go. P times the quantity of 1 plus R. All right. And we just need to type in our values. The amount is equal to $1,781 times 1 plus the rate of 0.09, and it's compounded twice. And let's say that the N, which is our compounds, which is 2 times 7. Someone type that into their calculator and then give me the answer. Maddie, $3,298.31. Very good. Our amount is equal to $3,298.31. You all do number 4 on your own. Do number 4 on your own real quick, guys. That seems a little bit high, Caitlin. Check your work. Seems like that's a little bit crazy. Hey, Caitlin, look on mine, make sure you have everything, but it also could be making sure that you're raising this to the power. It can get a little bit tricky the way you type it into your calculator. Okay, so looking at number 4, and Caitlin, I won't leave you. I'll come back to 3. Looking at this, A equals P times 1 plus R. Okay, so he invested $3,594 at a rate of 0.02% over compounded 4 times a year and then 4 times 11. So that should be your setup for that one. Okay. Now I'm going to come back over here, Caitlin. I'm going to make sure you're typing this in, Caitlin, on your calculator correctly. So I'm going to come over here and I'm going to type this in. Just trying to make sure we all see it. So that would be 1781 times 1, put parentheses, plus, and I'm going to put a fraction here, plus alpha y equals 0.09, and then put 2 in the bottom, and then make sure you're raising it, not just multiplying it. Raise that to 2 times 7 or 14, either one. And that's where we should be getting the 3298.31 at. Does that help, Caitlin? Do you see what you did wrong? Well, that's interesting. Caitlin, check your mode now. Of course, this isn't going to look like your TI-84, but mine's dead. But check your mode. Make sure nothing crazy is there. I don't know if that, or actually, hey, Caitlin, if you remember how to reset stuff. So second plus 7. So if you follow these steps, I would reset, look at your mode. Make sure your mode doesn't look like crazy. Like, it's in radian function, which that wouldn't do too much normal mode. Make sure all that looks good, okay? And then from there, if that still doesn't work, you could just go in and click on that, hit enter, and then hit enter again, make sure, and you can see without retyping the whole thing. And if that doesn't work, I'd reset the memory. So just hit second. I don't know what it is on there. On here, it's second plus, and then you just hit 7, and I think it's 120. 1, 2, yeah. So the RAM's cleared, and then try doing it again. It could be something like that. So it could be something to do with your exponents, Caitlin. Yeah, number 4 is correct. Christina, number 4 is actually what Bernice and Maddie put. So our amount here is 4475.95. Do you know where you made your mistake at, Christina? I didn't know if you saw it in your steps. That's why I started working that one. Okay, cool. Caitlin, any leeway? Any confusion cleared up yet after you reset it? Okay, so I'm going to assume. Okay, cool. So it's working now. Look at me. Give me 1 second. Let's. I'll be right back, guys. All right, cool. Here we go. Sorry, guys. My phone's about to die, so had to go change it. All right, so let's jump back into this. So now going to the back side. Okay, now what could we say? So think about this. Here's what I want you to think about. If something is compounded, let's say once a year, that would be that it's compounded annually. Okay? It's compounded twice a year semi-annually, 4 times quarterly, monthly, 12 times. But what would be the best? What would be like the best compound? Just thinking in the world of if you could make it compound any way, what way would you make it compound? Type that into the chat box. If you could make it compound any way, what way would you make it compound? Yeah, very good, Maddie. Very good, Josiah. Compound 24/7. Compound continuously, or constant compound, as Josiah called it. Okay. Now, you may think, well, okay, that would make some sense. So we're at a point there where we're saying it could be compounded, once a month. But then think about what if it was compounded, every single day it was compounded. Okay. Well, then you could take it further and say, well, what about if you compounded it every hour? And then, well, what if you compounded it every minute? And then what if you compounded it every second? But the cool thing about this is how many numbers are between 1 second and 2 seconds? Answer that. How many numbers are between 1 and 2? An infinite amount, okay? There's an infinite amount of numbers. Very good, Josiah. An infinite amount of numbers between any two numbers. So that's where this is like, when we say 24/7 constantly, we're saying that there is a way that it could just compound all the time, where it never stops compounding, okay? So let's say that I have $1, okay? Well, let's say I have $1. Write this down with me, please. Let's say I have $1, okay? And I earn 100% interest on that $1. All right? So, not giving you a timeline, let's just say $1. I have $1. And I collect 100% interest on that dollar. Okay? So, let's talk here about number of compounds. Meaning, how many times do I collect the interest on it? All right? So, let's say that it compounds 1 time. All right? So, we're not talking about time here. Let's just speak general in terms of compounds. So, if I have $1, it gets 100% interest, meaning I'm going to make that dollar back. Once it compounds, I'm then going to have $2. Okay? I'll have $2, and I can call this kind of like my value. All right? So if it compounded twice, well, we can kind of use our formula. 1 plus 1 over 2 raised to the second power. and we're not dealing with time. There's no, our initial amount's 1, so we don't have to write that there, and we're not dealing with time here. 1 is our interest, right? 100 as a decimal is just simply 1. So 1, our rate over how many times it's compounded, right? And then the number of compounds times the time, but we're not including time as a factor here. So that's 1 plus 1/2, which is 3/2. And then 3/2 squared would be 2.25. If it compounded 3 times, well, that would just be 1 plus 1/3 cubed. And that would take us to 2.37. $2.37. Well, let's jump it up a little bit and let's go to 10. What if it was compounded 10 times? 1 plus 1 over 10 to the 10th power. That would take us to 2.59374246. Just showing you the decimal just because. Well, then let's jump up. So like 10 times, we're almost like, if it was a year we're talking about, just depends on our time, and I'm not really showing you a time here. Just that's how many times it's been compounded, whether in a day, in an hour, in a year, whatever it may be. Well, let's say 100 times. 1 plus 1 over 100 to the 100th power. If you type that into your calculator, that will give you 2.7, $2.70, 481,38294. Then let's go to 1,000. If you're at 1,000, 1 plus 1 over 1,000 to the 1,000th power. That will give you 2.716923932. If we did 10,000, 1 plus 1 over 10,000 raised to the 10,000. That would be equal to 2.718145927. If I did 100,000, 1 plus 1 over 100,000 to the 100,000. That's going to give me 2.718268237. I could even go to 1 million. I could go to 10 million. I could keep going on here. And what do we see that's happening? Someone type in the chat box. What number are we getting around? What's the number we're it's starting to hover around? Yeah, very good, guys. 2.7. So, sorry about that. So, as n continues to increase, the number of compounds that we have, the value of the account remains very close to 2.71. And I'll say 2.718. Now, this special number is called the natural base. Sometimes referred to as Euler's number. Okay? It is what you will see as E. This number is irrational. Another famous irrational number is pi. Now, most of you guys know that pi is 3.141592654. Okay? And that's just a certain number of digits after 3.14. But most everyone knows 3.14. All right? That's pi. Pi deals with circles. Okay? If you really didn't understand where that whole pi comes from, let me take a second to maybe explain it to you. So in pi, now I know I'm kind of switching off topic just for a second, but I think this is important because a lot of people don't understand where pi comes from. So if we have a 2 by 2 square, okay, the area of that square, okay, is 4. And I don't know if you have seen this before. Have you all seen this before? If you have, I'll just be quiet. Have you all seen this before? Yes, no? Okay, cool. I think it's important that you realize where this is coming from. Okay? So if you have a 2 by 2 square, all right, the area is 4. Okay? But when you inscribe this square with a circle, the question would be this: what is the area of the circle? Okay? And this is where pi comes in. Okay? The area of a circle is pi r squared. Okay? Pi r squared. Now, you would know here, right? What's the radius of this circle? What's the radius of this circle? Can somebody tell me? What's the radius of the circle? 1. Yeah, very good. Because area, the radius is just 1 here, since that whole thing is 2. So that would just be pi times 1 squared, which is just 1. So the area is 3.14. Okay? Yeah, so your area of the circle is 3.14. So where that came from was like, and just like this example. But what they were able to do, you may be saying, well, where did pi come from? Well, how did they figure out 3.14? Because with calculus, you can determine the area under a curve. This area, this area, this area, and this area. Now, each one of those areas has a value of about 0.215. That has an area about 0.215. That has an area about 0.215. And that has an area of about 0.215. Now, if I say 0.215, 215, 215, 215, and I add those all up, 5, 5, 5, 5 is 20. 2, 3, 4, 5, 6. 1, 2, 3, 4, or 2, 4, 6, 8. I get 0.86. Keep in mind, the original square, it's a 2 by 2 square. So the square has an area of 4, but once you take out 0.86 for the corners area, you come to that 3.14. And ladies and gentlemen, that is where pi comes from. That's why pi is associated with circles. Because this right here works for, this is true with every circle. It's pi times the radius of the radius squared. And that's where the whole pi comes from. Does that make sense? Does that make a little sense of where pi comes from? And I could literally explain that to probably elementary kids and they would get it. If they knew area, I could show them that. Okay, cool. So I want you to know where pi comes from. And the reason I said all that is just so I just don't want you going forward into another class someday and be like, to be honest, I don't even know what pi is, what it represents, where it comes from. It's just the corners of a square with a circle inscribed. It's just the area of the corners taken out, and that's the area of the square. Okay? So, looking at E, okay? E is an irrational number as well, okay? And it can be used in different things, just like pi can be used in different things. But it's most of the time where you're going to see E at is E is the number, okay, when you're dealt with continuous compound interest, okay? So as this number approaches infinity, we're at 100,000, we could go to 1,000,000. As this number right here, as the n number of compounds approaches infinity, the x approaches positive infinity. Okay? So I'm going to write that down. The value that the expression (1 plus 1 over x to the x power) approaches, this is in behavior, guys. The value that the expression 1 plus 1 over x to the x power approaches as x approaches infinity, as x approaches, is positive infinity. Okay? So E is that value. E, the value that this expression approaches as x approaches infinity is E. So this is almost like one of those basic functions, okay? It's one of those basic functions, and you'll see more about that in the days to come. Okay. Now, if I was to look at my calculator, okay? If I was to look at my calculator right here, the E is right here, right below pi. It's the slash mark, so it's right below the caret top and pi. And I can type in E, okay? And if I hit enter, I get a number, 2.718281828. Okay? And that's 5. And the calculator actually rounds it, guys. Okay? The calculator rounds it. So, this number is actually equal to, and it's an easy way to remember it, guys. It literally is. And you could just become a genius if you ever ask what's E and what several digits after it. It's always going to be 2.7, okay? 2.7, and then it's 1828 twice, okay? 1828, 1828. Okay? 2.71828, 1828. So 2.7, 1828, 1828. And then the next 6 numbers are easy as well. It's just 45, 90, 45, which are the angles of an isosceles triangle. A triangle with the same angle down here at the bottom. Isosceles triangle. 2 angles are the same. So you need to know what E is, okay? So E is just not going to be this random number that, oh, well, I really don't know. You know, my teacher just said, hey, here's E. E is what the value, this right here, exponential values approach, okay? As x goes to infinity. As x right here, as we increase that number to infinity, you can put 100 in there, 200, 5 million. Whatever it's going to be, it's going to approach 2.7, okay? And then you'll kind of see in the days to come that is e raised to the ex power. So if you have your calculator, if you have your calculator and you were to do e raised to the x power, it's going to give us an exponential graph. And that's what e raised to the x power looks like, which should be extremely close, guys, to what we've been seeing thus far. Okay? So that's e raised to the x, which is almost like another basic function that you know. We can move it, we can shake it, we can do anything we want. Because don't get it wrong. On our notes, keep in mind, that's just 1/2 to the x power. That's 2 raised to the x power. This is just e, which is also a number raised to the x power. So it is a type of exponential function, okay? And you'll learn more about e in the days to come, okay? So, like I said, today's more about the understanding of stuff than it is just pure math, okay? More about increasing your knowledge. So that's just some, sorry, I was off my screen. It's calculate 84. And it does everything that the TI-84 calculator does. Only problem is you can't use it, on a test or something like that, because then you'd be cheating. All right, sorry, going back. So now I create a formula for something that's compounded continuously. Continuously compound interest formula. So interest that is compounded all the time, okay? Continuous compound interest formula. I have a question without you Googling it. That sounded funky coming out, Googling it. Without you Googling it, can someone tell me what that formula would be? Can somebody tell me what that formula would be, actually? You have all the knowledge you know. You have literally all the knowledge you need. Anybody want to take a stab at it at least? Yeah, very good, Christina. So, hey, great. Hey, so what does E replace here? What is E replacing? Okay, hey, not bad, Elizabeth. Could be possibly onto something. Kelsey, don't retract that message. Send it back. A is equal to P. No, you're fine, Elizabeth. I'm just glad you're in class today, Elizabeth. A is equal to P, and then Kelsey wrote it, but she retracted it, which is all right, Kelsey. I'm not a hater. It is actually P, and then E raised to the RT. P is your principal, because watch this, guys. No matter what X is, this represents continuous compounding. Okay, this is not one compound or 12 compounds, or it's compounded semi-annually. This is the infinite amount, and what this number right here is equal to is E. So we take out, basically, if we go back to the front, we're taking out basically the 1 plus R over N to the nth power. No, just the E is raised to the R over T. So think about this. If E equals this right here, then that is literally what we're taking out. Okay, that is literally what we're taking out here, this whole thing. And the only thing we don't have in there is the R, so you raise it with the power, you multiply it times T. Hey, give me a thumbs up if this is making a little bit of sense, guys. I know it's a lot coming over, the internet and stuff, but give me a thumbs up if this is making a little bit of sense to you. All right, good, Kelsey. Kelsey, you almost had it. Okay, not bad. Not bad. Cool. All right. Now, again, I want you to have that deeper knowledge. I want you to have the deeper knowledge of what's happening. I couldn't teach this to another class because they would just be like, hey, man, just give me that formula and we're good. So, and that's the way it has to be taught. But you all need to know the basic behind, hey, where is E coming from? Where is pi coming from? Where are all these numbers that we come up with come from, okay? E comes from a exponential function, okay? And something that is compounded continuously, that is the number it approaches. So, Eduardo invests $6,029 in a savings account with a fixed annual interest rate of 2% compounded continuously. What will the account balance be after 4 years? Okay? Now again, guys, we're just going to use this formula. Going back to that whole dollar thing, guys. Even a dollar with 100% interest, even if I compounded an infinite amount of times, it's only going to take me to $2.71. Okay, so compounding, okay, it will, although you can go to infinite, it's going to approach something. Okay, so I know it sounds confusing. It's like, oh, if it's compounded infinitely, that means it's going to grow rapidly and so fast it's crazy. While it will grow quick, it's not going to be astronomical large or anything. All right. So here we go. The amount, right? Our formula. The amount equals P raised to the RT power. So A is equal to P is the principal, 6,029. E raised to your rate as a decimal, 0.02, and they want to know after 4 years how much money will you have. And that would be A is equal to, now I'll type it in once to my calculator here so you can see it. So I would say 6,029 second E raised to the 0.02 times 4 power. Okay, 6,029 probably see it a little bit better that way. 6,029 E raised to the 0.04. Can't zoom in, sorry. 0.04 times 4. I hit enter, and I get the amount of 6,531.14 when I round to the nearest cent. And that's how I would type it into the calculator. And that's the way the cookie crumbles, guys. Again, the work down here is the easy part. I care more about your knowledge of you understanding kind of how compound interest and continuous compound interest works. A equals P to the R over T, or raised to the RT. A is equal to, he invested 3,659 at a rate of 0.09, and they want to know how much it'll be in 11 years. Someone type that into the chat box. Yeah, very good. That's it. $9,847.23. Very good. Looking down here, Amy invests $7,135 in a retirement account with a fixed annual interest rate of 8% compounded continuously. What will the account balance be after 17 years? Amount is equal to PRT. Amount is equal to, she put $7,135 in there. E, the rate, 0.08 times 17. Someone get that calculation. Type it into the chat box. Very good, guys. Both of you. Excellent. 27,799.34. Very good. If you're not getting that, let me know if something's wrong with your calculator or something's happening. And number 8, you guys go ahead and work that out. Type, get it in, and then someone shoot the answer in the chat box. Yeah, very good. 9,000. That's right. $9,168.25. Okay, guys. Hey, we talk about like investment, and I've showed the last lecture we had. We talked about exponential graphs, and we talked about Ben and I forget the other guy's name with the Roth IRA and investing at a very young age. What is the key component for your money growing? What is it? Is it the amount of money you put in? Is it the time you let it grow? Is it the interest rate? Is it the bank? Is it the economy? What is the key factor for anything to grow at a good rate? Yeah, that was Ben. Yeah, whoever it was. Cool. And yeah, Elizabeth, Maddie, and I'm sure the other ones as you guys are typing it in, the key word is time. Okay? Now, if this was a more of a in class discussion and we're sitting there and we're talking about stuff, this would be one of those times where I shoot it to you straight. Okay, is that time matters. Okay, if for anything to grow, for you to grow as a person, for you to grow as a Christian, it takes time. One of the biggest things in the Christian world that I think is so hard for people to overcome in coming to church and coming to God, and I may just talk about this just for a second. I hope that's okay. But one of the biggest things that what people don't realize is people don't give other people time to grow. All right. I've seen people, and I'll use some other examples, but I've seen people come into church before, and because they didn't give up these restrictions that are ungodly or we would deem as ungodly, just because they didn't give those up in like the first week of them giving their life to God or whatever you may call it, it's really sad, because then a lot of people leave the church because they feel like they're being judged and they feel like they're constantly being, well, you look at me. But I think if I could encourage you guys to do anything, even among your friends who struggle with their walk with God, friends who are struggling, you got to give people time to grow. And us guys in this class, I don't know how many people are in this. I don't know how many more guys are here, but it takes guys a long time to mature. So we mature way later than you girls do. So it takes time, okay, for anything that is going to be good takes time, okay? So that's just an example. If you're going to be good at sports, you're going to have to invest in the time. I don't know how many of you watched the MJ documentary last night, but one of the most powerful things coming from the MJ documentary was that when he walked into a hotel room his rookie season at the very beginning of the season, and he walked in and they said, look, there's drugs here, there's drugs there, there's girls here, and you got whatever you want. MJ literally turned around, walked out of that room, and said, hey, man, only thing I'm doing is working. I'm just here to play basketball. And what's so cool is we've never seen that side. This is like some of the newly released videos and stuff. And it just kind of made me think, man, I got to stay in tune. I got to stay focused on work and time. One more example I want to give you just here, and I know I've gone a pretty decent time today, but hey, you only got me two days a week. But one of the things that something that is really cool to me, and let me show you my screen real quick. One thing that to me is so cool is let me show you this. So, and I know I show you a bunch of stuff all the time, and obviously this whole change your life with one calculation, and it's talking more in terms of money wise. So this is how a single $1,200 investment grows with compound interest. Compound interest is what we're talking about today. So if you invest into a single $1,200 investment into an account, one of these accounts, whether it be a savings account, money market fund, or CD, or the stock market, and they say traditionally it grows at 9%. Dave Ramsey says the stock market traditionally goes at 12% for the past 40 years. This probably includes the Great Depression, which kind of tanks it. So, one-time investment of $1,200 after 40 years. Once you give something time, it will grow. Okay? It will grow. So, do something and give it some time, it will grow. But that's a one-time investment of $1,200. But we talked about this. You invest $1,200 every single year. So this is investing $1,200 one time, guys. And you end at 40 years, you end with $37,000. You invest $1,200 a year for 40 years, and you're at $500,000. And that's all because compound interest. And what is compound interest? Compound interest is interest earned on interest earned. Okay? But as I was kind of looking through this, I found a really cool story about, it says, this amazing tale, the Mississippi woman washer. Okay? I don't know how well you all can read this, but I'm just gonna read it real quick. So I don't mean disrespect by butchering her first name, but Osleo McCarty was born in Mississippi in 1908. For nearly 75 years, she lived in the same simple house, washing other people's clothes for a living and putting whatever money she could into a savings account at local banks. In the summer of 1995, Miss McCarty made local and then national headlines when she donated $150,000 to the University of Southern Mississippi to establish a scholarship fund. I just figured the money would do scholarship recipients a lot more good than it would do me. She said, it soon came out that this washer woman, had managed to amass nearly $250,000 over a lifetime. Now, that doesn't sound like much to us, but in 1908 and 1930, the Depression, in 1950, when stuff was dirt cheap, $250,000 is a ton of money, guys. And as we are talking here, time is a key part of the compounding equation. Of compound interest, the key is time. And it helped turn her meager early investment into hundreds of thousands of dollars. And the ending is a lot. They say it's a lot. The ending's better. As remarkable as Miss McCarty's story is, the end could have been a blockbuster. After she died in 1999, one of her bankers wrote to us saying, "Time was able to turn even the modest returns of our early investment into hundreds of thousands of dollars. If we would have been able to introduce her equities earlier, she would have left with millions instead of thousands." Again, I think Christina said it. The key is to start early, okay? To start saving early. So I don't care if you're mowing yards, babysitting, whatever you're doing. Start saving your money. The key word that I would point out to you guys is that this right here. She lived in the same simple house. I'm telling you guys, it's about simple. You ain't got to have nice. You ain't got to be perfect. You ain't got to be beautiful. Just keep it simple. Keep it simple. Save your money. And I think you could go pretty far in life. I just wanted to kind of share that with you, just to kind of give you a visual of Miss McCarty. Here we go. I can just copy this real quick and then paste. Just to kind of give you a visual of her. And here she is, born in 1908. That's her right here. Okay, so I don't know, just a cool story. I love to hear people's stories about, their lives and stuff. And she just washed clothes, lived in the same simple house. So very, very unique woman. So just giving her a spotlight today. And if you often think that you often think about it, once these people think about this woman died over 20 years ago, but yet her legacy lives on because she, just did something simple like give and donate. So pretty intriguing, I would say, to say the least. But just wanted to kind of share that with you all. I thought it was pretty cool. So I don't know. You may think, man, Mr. Rappaport, that was dumb. But it's all gravy either way. But that concludes this lesson. Do I have any questions? Any questions about anything? If no questions, give me a thumbs up that you are good and you're seeing this and you're ready to start 6.2 homework. All right, very good, guys. Hey, thank you so much for your attention today. You guys can be dismissed. Look forward to seeing you guys Wednesday. We'll discuss 6.2 homework and do 6.3 notes. See you guys then. You're dismissed. If you have any questions, feel free to type them in. I'll be here for a few minutes. Thanks. You guys have a good day, too. Good day, Christina.